In this example, we're going to graph the polar equation r equals 2 times cosine of 3 theta. Now this is going to make a special type of graph, and because of that, I'm actually going to adjust the points that I would typically use when graphing a polar equation. Instead of the normal points that I often personally use, which would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. I am instead going to come up with a different set of values. The values that I'm going to come up with are based on the value that we see here that is multiplying theta on the inside of our trigonometric function. If I see a number that is going to be multiplying theta, what I'm going to do to my standard set of initial values is I'm going to take all 5 of those and I'm going to divide them by 3 first. And I'm going to use those values instead. So, for example, 0 divided by 3, that is 0. I will still use 0 in this case. Pi halves divided by 3, that is also the same as pi halves times 1/3, which is pi over 6. Pi divided by 3, that is just pi thirds. 3 pi halves divided by 3, that is the same as 3 pi halves times 1/3, which is pi over 2. And 2 pi divided by 3 is just 2 pi thirds. So, what I have done is just come up with a more specialized set of values for theta that I'll be using when trying to evaluate and come up with points on the graph for r equals 2 cosine of 3 theta. It is fine if you choose not to do this. However, incorporating this method is going to help get you very nice values that will really demonstrate what this curve is actually doing. Let's see why. If I use all 5 of these values and plug those into r equals 2 cosine of 3 theta, I will get 2 cosine of 3 times 0, which is cosine of 0, which is 1. So that'll just be 2 times 1, or 2. If I plug in pi over 6, 2 cosine of 3 times pi over 6. Well, 3 times pi over 6 gets back to pi over 2. And cosine of pi over 2 is pretty nice. That's just 0, giving me an overall value of 0. If I plug in pi over 3, 2 cosine of 3 times pi over 3. Well, 3 times pi over 3 is just pi. And cosine of pi is -1. 2 times -1 will give me -2. Notice that what we have done is that we have created my values for theta so that what I end up getting here are just values of 2 times the values that we would typically use when graphing cosine. 1, 0, -1. The pattern will continue from here to give me 0 and 1 for the next 2. As shown here, 2 cosine of 3 times pi over 2. That's cosine of 3 pi over 2, which is 0. Overall giving me 0. And then 2 cosine of 3 times 2 pi over 3, which is 3 times 2 pi over 3 is 2 pi. And cosine of 2 pi is +1. Which overall gives me 2. So, yeah, I ended up just getting 2 times these familiar values for cosine. So I've adjusted the original inputted values so I can make this occur. That is very nice and convenient for me. Plus, it's actually going to demonstrate what's happening with this curve. Let's see what that looks like then. Starting with my first point. My first point is 0, 2. So that means face towards 0 radians and go a distance of 2 in that direction, which puts us here. The next point I have is pi over 6 is what we inputted. Pi over 6 and 0, which means face towards pi over 6 and walk a distance of 0 radians, which puts us right back at the pole. Well, from those 2 points, I know that I am curving back towards this point at the pole, as these values are implying that as I rotate counterclockwise, my radius is getting progressively smaller. So I'm rotating back towards this direction. My next point is at pi thirds is what I plugged in, and I got -2 in response. So that means face towards pi over 3 and walk a distance of -2. So that actually pushes us back into, in the Cartesian plane, what would be quadrant 3 over at this point here. And that curve seems to naturally flow into the next point then. Just like that. But the next point is really going to demonstrate what's happening. Pi over 2 and 0. This means that we are facing towards pi over 2, but we have a radius of 0, which puts us right back at the pole again. Meaning that I'm going to be curving right back towards the pole, which is a little bit strange. Seem to have this enclosed loop of sorts. And if I go to the next point, which is 2 pi thirds and 2, this means we face towards 2 pi thirds and walk a distance of 2 in that direction, which puts us up here. That seems to flow naturally from my previous point of this curve, so I've curved out and back in towards the pole, and it looks like I'm curving right back out again, back to this point. Now, this isn't the entire curve. If you want to create the entire curve using more coordinates, then I would suggest to try to plug in 5 pi over 6 and pi. This is going to finish up the rest of the graph. However, we shouldn't need to do that. At this point, we're going to use concepts of symmetry to try to complete this, as well as the fact that over here, we saw this kind of loop, which means that we're probably going to see that happen again with the other values that seem to go out the same amount of distance from the origin. When I'm at this point here, I'm going to curve right back towards the pole again. And then as I curve back towards the pole, that seems to naturally flow back to right where we started. This is going to be the equation of, or the graph of this equation of r equals 2 cosine of 3 theta. And this graph has a special name. This is a rose.